Today we're going to look at polynomial graphs and their interval slopes. When I hear about the word slope, first thing comes to mind for me, y equals mx plus b. M is that slope. What that means is how steep a line is, really, how steep that hill is. So here we're going to talk about different hills that go up, down, and all that. So when you read a book, we go left, right, top, down. I want to read these graphs left to right. So if I'm looking at this first graph and I'm reading this direction, it looks like this line goes up. Where does it go up? Well, we'll say there's a little wall right there. From infinity going down all the way up to this little wall, we say that that's increasing. Why is it increasing? Because as I read, I kind of take that line up. But the second that I hit that top point, that vertex, I'm reading and all of a sudden I'm going down. As I'm going down, that's decreasing now. All right, so middle graph here. If I start all the way over here and I move in the right direction, this graph is moving down till I get to that little vertex there. So from here to the wall, as we read this way, that line moves down. We say that that is decreasing. But once I hit that point, and from here to here, as I'm reading, that line goes up. So from there to there, we now have increasing. And then once we hit that last point, as we read and move to the right, this line goes downwards, decreasing. So slopes, we're looking at each individual chunk of line and we're saying whether or not that line goes up or that line goes down. The word interval means we're looking at pieces of the graph. So we're looking at this half of the graph over here. We're looking at the second half there. We're looking at this chunk of graph, the middle chunk, and the last chunk. Each group of the graph is split by where these vertices are. So it's where that graph makes that turn for the hill to valley. All right, so this last one here, this one's going to get a little weird. I have all my vertices down, so I'm just going to draw little walls to help make things a little clearer for me. And rather than writing increasing, decreasing, and all that, I don't have enough room. So instead, off to the side here, I'm going to write it in a different notation. So this line, now I want to talk about left and right for a second. I'm going to say that this graph forever goes down, but it also very slowly kind of moves out to the left over here. But it's forever going that direction. What number is that? Well, it's kind of in negative infinity. And we're going to talk about till we get to about -3. This chunk of line right here, if I'm reading to the right, is that a hill going up or a hill going down? We're going to say that this is a hill going up. So we call that increasing. Now we're looking at from here to here. So that's going to be -3 to -2. -3 to -2. This line goes downward. We say decreasing. Let's talk about -2 to -1. We now are reading our line move upwards, increasing. From -1, and this thing goes all the way down to here, so that's at +1. As we move to the right, this line goes downwards, decrease, and from +1 to, this thing goes to infinity now. We're back to the increase. So I have two different ways of looking at this rather just writing increasing, decreasing on the graph, or splitting it up between each little interval, each little chunk of numbers where those hills and valleys change. And that's polynomial graphs, interval slopes.